So we've been talking about fractions, and today I want to start looking at adding and subtracting fractions. And that's probably something you've done before, but we might do it a little bit differently today than what you're used to. We're going to start with just a physical model or a visual model. When we look at this, it should be pretty easy to see that in this first picture we have 2/7 because there's 2 pieces shaded out of 7 pieces. The second picture shows 4/7. And if we put those together, we're going to end up with 6/7 or 6 out of 7 pieces shaded. Let's look at another example. In our next example, we have 5/7 shaded, 5 out of 7 pieces, plus 4/7 shaded. And if we put those together, we can see from our picture, we're going to be able to fill up one hole, but that doesn't include all of our purple pieces here. So we need another 2 pieces. So we get 1 whole and 2/7. And we could have thought of that actually, if we wanted to, as if we just looked at the sevenths, we would have counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 9/7, and that equals 1 and 2/7, which we can see pretty easily from our picture. Now, if we looked at this as subtraction, you can see that we have in the first picture 4/5 shaded. In the second picture, we have 3/5 that we want to subtract from that. So if I have 4/5 and I take 3 of the fifths away, I'm going to be left with 1/5. So just looking at these 3 examples, these 3 models, it should be pretty easy to see that we can just take the numerators and add or subtract them, whichever kind of problem we're doing, but the denominator has to stay the same because the denominator is just telling us how many pieces are in the whole. The numerator is telling us how many pieces we actually have. So we're either combining the pieces we actually have, which is addition, or we're subtracting the pieces that subtracting some pieces from the ones that we have, which is subtraction, of course. So we have to have the same denominator in order to be able to do that, of course, though. So if we look at one where we don't have the same denominator, this picture shows 1/2 plus 1/3. But the problem is if we go to this last picture and we want to see what it equals, we can't do that because all the pieces are not the same size. So that's where this idea of a common denominator comes in. So what we can do is we can think of, well, really 1/2 is the same as 3/6 and 1/3 is the same as 2/6. If I add those, then I'm going to have 5/6, which matches our picture above, but it makes a lot more sense because all the pieces are the same size. So that should be just a good review for you that we have to have a common denominator in order to add or subtract. And let's look at some other problems now. Now, we're going to look at some problems that are a little bit harder here in a minute. But before we do, let's talk about what our rules would be then for adding or subtracting. We have to have a common denominator. That's the first rule. We have to find a common denominator, and we have to make both fractions have that denominator. Then, if we have a mixed number, we're going to have to change those to improper fractions so that we can add or subtract the numerators, which is our step 3, and keep the denominator. If we get an answer that's a proper fraction, we can simplify it. If it's an improper fraction, we can convert it to a mixed or whole number and then simplify it, if we possibly can. So let's look at that in action. You may have learned some different steps before. You may not have learned to change the mixed numbers to improper fractions. But if you haven't learned that before, you're going to see how that's a benefit. It's going to take away any borrowing or any carrying that you've had to do with the whole numbers in the past. So let's look at this. Our first example is 7/8 minus 5/8. Now that's a pretty easy one. 7/8 minus 5/8. Step 1 was to make them have the same denominator. They already do. Step 2 was to make our mixed numbers into improper fractions, which we don't need to do that because we don't have mixed numbers. And then we can add or subtract the numerators, which we're going to subtract them. 7 minus 5 is 2. We get 2/8, which equals 1/4. Our next example is a little different, though, because we have mixed numbers here. And so for this one, I'm going to start by changing them to improper fractions. I could, if I wanted to, find a common denominator first, make the fractions have a common denominator, then make the improper fractions, or make the mixed numbers into improper fractions. Really, you can do that step in any order. I'm going to change them to improper fractions first. So 8 times 4 is 32, plus 3 is 35. So I get 35 eighths. And 4 times 5 is 20. 20 plus 1 is 21. So I get 21 fourths. Now, they still don't have the same denominator, so I have to make them have the same denominator. So I think about 8 and 4. What's a number they both go into? The easiest one in this case is just 8. So that means 35 eighths can stay 35 eighths, but 21 fourths has to be changed to 42 eighths. Has to be changed to an equivalent fraction with a denominator of 8. Now, this problem becomes easier. Now, I can just do 35 eighths plus 42 eighths. And if you needed to kind of do the 35 plus 42 off to the side, that's perfectly acceptable. So I'm going to get 77 there. So I get 77 eighths, which is an improper fraction, so I'm going to change it to a mixed number. 8 goes into 77 9 whole times, because 9 times 8 is 72. And I'm going to have 5 left over. So 9 and 5 eighths is going to be my answer to that problem. Now let's look at a couple more examples. 6 and 5 twelfths minus 2 and 7 twelfths. I'm going to change these to improper fractions. So when I do that, 12 times 6 is 72. 72 plus 5 is 77. So I get 77 twelfths. Minus 12 times 2 is 24. 24 plus 7 is 31. So I get 31 twelfths. Those have a common denominator, so I'm ready to go ahead and work it out. 77 twelfths minus 31 twelfths. Again, if I need to do 77 minus 31 over to the side, that's perfectly fine. 77 minus 31 is 46, so I get 46 twelfths. 12 goes into 46 3 whole times with 10 left over, so 3 and 10 twelfths, which I can simplify to 3 and 5 sixths. So 6 and 5 twelfths minus 2 and 7 twelfths is 3 and 5 sixths. Let's look at one more example, and then I'm going to let you try some on your own. 9 tenths and 7 eighths. Those are both in fraction form already, so I don't have to change to improper fractions. And I can find a common denominator. I'm going to start by thinking about, looking at my denominators are 10 and 8. I'm going to pick my bigger one just because it's going to get me there faster probably, and think about its multiples. 1 times 10 is 10. 8 won't go into that. I can't use it as a common denominator. 2 times 10 is 20. 8 doesn't go into that either. 3 times 10 is 30. 8 won't go into 30 evenly. 4 times 10 is 40, and 8 will go into that. So I can use 40 as a common denominator. Now, 10 times 4 is 40, so then I do 9 times 4, which gives me 36 fortieths. 8 times 5 is 40, so I do 7 times 5, which is 35. Now I've got 36 fortieths plus 35 fortieths. So 36 fortieths plus 35 fortieths equals, if I need to do it up here, 36 plus 35 is going to give me 71. 71 fortieths. 40 goes into 71 one whole time with 31 left over, so I get 1 and 31 fortieths. All right, let's have you try some on your own. Here's two problems that I want you to give a shot to, and they do take a little bit of work, but I think you can do it. Take a moment to pause, try both of those, and see what you come up with. When you're done, move on to go ahead and hit play and check and see if you were correct. All right. For the first one, I got 55 sixths minus 23 fourths. When I found a common denominator of 12, that gave me 110 twelfths minus 69 twelfths. 110 minus 69 was 41, so I get 41 twelfths. 12 goes into 41 3 whole times with 5 left over, so I get 3 and 5 twelfths. For the next one, oops, I got a little bit of ink work to do there. For my next one, I got 7 and 11 twelfths. Let's fix that. 7 and 11 twelfths equaled, all right, 7 and 11 twelfths equaled 12 times 7, which is 84. 84 plus 11 is 95. So I get 95 twelfths here, and 95 twelfths for the first one, and then 3 and 5 ninths equals 32 ninths. When I change that to a common denominator, I'm going to use 36 as my common denominator, and 95 twelfths is going to equal 285 36ths. 32 ninths is going to equal 128 36ths. When I subtract those, I'm going to get 157 36ths, which equals 4 and 13 36ths. Now, yeah, that's kind of hard in terms of getting some big numbers to work with, but the good thing is that you can use the exact same steps no matter what kind of problem it is. You don't have to worry about any borrowing or any carrying. You might have learned about that in the past. If you're really good at that, great, go with it. If you struggle with that, then this is a great way to do it. This is a great alternative method. But you do have to maybe work with some bigger numbers. Let's look at a couple more examples. 5 sevenths plus 4 sevenths, and 7 minus 2 and 5 eighths. Take a moment to pause, try those problems, and then hit play once you've tried them. All right, the first one's fairly easy. 5 sevenths plus 4 sevenths. 5 plus 4 is 9, denominator 7. So 9 sevenths is equal to 1 and 2 sevenths. And the second example, this is a little trickier. So since the 7 is a whole number, we do need to have a fraction in order to change it to an improper fraction. So some people would say, well, why can't I just make it 7 over 1? And you could, but then you don't have a common denominator. So it's sort of easier to think of it as 7 and 0 eighths and use 8 as the common denominator since your other fraction, or since your other mixed number rather, has a denominator of 8. So 7 and 0 eighths is equal to 56 eighths. 2 and 5 eighths is equal to 21 eighths. When I do 56 eighths minus 21 eighths, I'm going to get 35 eighths, which equals 4 and 3 eighths. Let's try one last example. 8 and 2/3 plus 5 and 4/5. Take a moment, pause, give it a try, and hit play when you're done. All right, now that you've tried it, take a look. 8 and 2/3 equals 26 thirds. 5 and 4/5 equals 29 fifths. Common denominator is 15, so 26 thirds is equal to 130 fifteenths. 29 fifths is equal to 87 fifteenths. So when I add 130 fifteenths and 87 fifteenths, I'm going to get 217 fifteenths, which equals 14 and 7 fifteenths. Again, if you are more comfortable with borrowing and carrying with mixed numbers and things like that, you can certainly do that. But by changing the mixed numbers to improper fractions, then you're not going to have to worry about any of that. And also, when we get to multiplying and dividing fractions in mixed numbers, since that's one of the steps in multiplying and dividing fractions in mixed numbers is to change mixed numbers to improper fractions, then you're going to just always automatically do that. So it keeps you from making mistakes later on with multiplication and division because you're going to be used to having to change your mixed numbers into improper fractions.